Are you ready for the test? Very good. So we have 8 minutes left.
Sir, is it that we'll solve it in our notes, then snap it and send it to the group?
All right. So I believe you all understand the instructions now. Do you have anybody that wants to give? Okay. So this is the instruction, guys. We are spending 20 minutes. We are starting the test by 10:30. So we have 4 minutes left. So we are starting with chemistry first, then to biology. So you're expected to use 10 minutes on each subject. Is that taken? Once we start, after 10 minutes, the I will close the tab for biology. We're starting with chemistry. I will close the tab for chemistry. Then we will move to biology. So if you are not yet done within that 10 minutes, so it is that's your own cup of tea. I want to make sure you guys are fast while answering your questions. So after chemistry, we will move to biology. and it should be done also 10 minutes. Each subject contains 20 questions. There are diagrams also there. Start taking. So 10 minutes for each subject. That's 20 minutes or total. So I can give you a grace of 5 minutes, make it 25 minutes. So by 11 a.m. at most, you are expected to submit all your answers on the group. If you are typing, type on your phone and submit it immediately. If you don't submit before 11 a.m., that means you are not yet. Is that it? Please, are we all clear? Ah, William, what happened? What's the issue? Hope everything is fine there. Okay, very good. So we have 2 minutes to go. So how many students do we have in class presently? We have 7. Paul, Gift, Lillian, Fermi, Justice. Suzanne is not here. Adini is not here. Benita is not here. Is Confidence here? Confidence is here. Okay, Benita is here. Confidence is here. Stephanie is not here. Shadrach Motors is not here. Okay. So that means 7 people are doing the questions are very simple actually. Okay, so this is 10:30 already. So guys, we are starting. So we have 8 students for this class. I wish you best of luck. All right. Saying I can't share my screen. Okay. Oh God. My screen is not sharing. Titi. Okay, we have 9 students.
Good morning,
So
sir.
please, nobody should write it out on a sheet of paper and write your name on the top. Your time starts. This 10:33. So the chemistry is just for 10 minutes. And your time starts now. Tear a sheet of paper, write your name, write chemistry. You can't see. The issue is from your hand though. Can others see the board? Gift, can you see it? Okay. So Lillian, please rectify it. Your time is going already. So we started this class 10:30. Anyway, I will be the one to scroll up for you. By now, you should be done with question one, question two. Should be. If you came in and that's your own issue, I asked you to be here by 10:30. Don't know what I said. That's question one. Should be done with question one. Should be done with question two. Should be done with question three now. Should be done with question four now. Zoom your screen. Zoom your screen.
Sir, please move back to number 7. Number 7, I missed it.
Uh, you guys have less than say 6 minutes. Oh, okay.
So come down a little. So we'll see question 15. This-
What happened?
Sir, please go back to number 17.
You are dragging us, so your time has gone. You've used 15 minutes already. You guys, are not keeping with times. These questions are very simple jam questions.
Sir, 19.
So let's move to your ballot. Sorry, the system is not sharing ballot. So this is 10:47.
Papa, what should we do with our answers?
What did you say?
Our answers, what should we do with them?
Your answer
Uh,
for what?
chemistry.
For chemistry.
Chemistry test now.
I can't hear you properly. Maybe you should type. Lillian, if I catch you, 1 to 4. If I catch you, I will strangle you. So I believe we are done now. So this is 10:58. Before 11, everyone should submit the answer on the group.
It's already 11 at my end.
Yeah?
At my end, it's already 11.
In the next 2 minutes, submit your test. Mine is 10:58.
Sir, please 13 to 16.
Submit your answer.
I didn't
Lillian,
see questions from 13 to 16, sir.
Lillian, this is 1 to 5. Can you see?
Sir, I mixed chemistry number 7 question.
Chemistry is a law. Chemistry don't go.
Ah,
Tell you. 13 to what?
16.
What is between the upper epidermis and lower epidermis? I taught you.
Yes.
You have less than 1 minute to go. So you guys, you can submit. I'm expecting this. Okay, Titi, you submitted. Out of 10 students, only Titi has submitted. Well, I mean, you submitted. Matrix, you submitted. That's the way people.
I've submitted.
I've not seen you. I've already sent you. Who is Matrix?
Okay, I'm the one, Justice Matrix.
Justice, okay. Paul, you submitted. Gifts, Lillian. I will close it now. Once I type now, nobody should submit after my message. You want to derive other people's answer. Okay? Benita, confidence, easy. Okay? I will close it up now. So after this, nobody should submit again. Gifts. What I will do for you, eh? You will not like yourself.
So I'm coming. I'm trying to tidy my work.
So confidence, you did not submit. Lillian, you did not submit. Okay, Lillian submitted. Nobody should submit again now. Okay.
It's not even clear. So when I'm rushing,
You know what?
I said the picture.
I can't hear you.
No, I was talking to myself. I didn't know that I was muted. I said the picture that I sent is not even clear.
It's not going.
It's not clear. I've sent it, but it's not clear. I will send it.
All right, so let's continue from where we end the last class. So after marking it, we will do the correction in the next class. So let's move to chemical bonding. The questions are simple now, everybody. Are they not simple? Justice,
Sir? Oh, God.
are they not simple?
I'll not answer for everybody.
It's simple for you, Abby.
Not that. Some places, so.
Okay. What about you, gifts?
It was okay.
It was okay.
Yes.
Okay. Suzanne ran away. If I catch that girl.
No, sir, she
Yeah,
didn't run. She's not feeling fine. She's not feeling
she's
well
not.
at all.
I know you will speak on her behalf. Uh, so I'm coming up. My pen is not working. So we are going to chemical bonding today, and the essence of chemical bonding is to obtain a stable noble gas configuration. Do you know what noble gas is? When there is no uh, extra valence electron, when an element or atoms they have a complete electrons in all the shells. You know, the first shell should have two, while other shells have eight. So anytime an electron has this complete configuration, we say such element has obtained a noble gas configuration. So I don't know why my ink is not showing. What's going on? Yeah, I will dictate for today. I'm sorry. I'm just trying to set up my system, and the ink is not. It's not bringing anything for now.
So I even thought this chemistry test would be more of calculations.
What do you say?
I even thought it would be
Swear.
more of calculations.
I
So
swear.
I concentrated on calculation.
Okay, for chemistry, I mean,
Yes.
like I was setting your question in the midnight, actually, like around 4 a.m. I have a class in the morning. So as I was doing it, my system crashed. Like I was working on a project on an every file, so it crashed. So I had to reload the system again. So that was what happened. You can see the questions are very simple. This is not my plan. I actually had a better plan for you guys. But for your mock exam, don't worry. During your mock exam, everybody will be on the webcam. All your webcam will be on so that we can monitor you. And your mock will be a standard question. Everybody will have their respective time count. So once your time elapses, the question will go from your respective places. So since my ink is not showing for now, let's just continue. So the first thing we are doing today is ionic or electrovalent bond. That's the first bond that we are checking today. So maybe I'll be typing. Wow, that's yes. Ionic or electrovalent bond. So when it talks about ionic or electrovalent bond, it entails transfer of electrons. And the transfer of electrons is always between metals and non-metal. What did I say? It entails transfer of electron between metals and non-metals. That is ionic bond. For example, sodium. I need to write it. This is serious. Oh my God. So I'm coming up. I want to see if I can set it. Oh God.
So I tried rebooting it now.
What do you say?
I said maybe you should try rebooting your system.
Yes, I need to restart actually. But if I should restart, it will take like 20 minutes because I'm just reloading all the windows. So, and I can't do that after the class. So, I think that's part of the reason why the graphics pad is not working with it. But let me see what I can do. I will just do a summary today. Maybe we'll do the next class. Maybe tomorrow. We'll find a time. Maybe an hour tomorrow to do a proper class. So that would be what we're doing. It's not bringing anything for now. I will have to restart the system. Okay, so are you guys with me, please? So sorry for the inconvenience. I apologize. So, like I said, what did I say? Ionic or electrovalent bond are. Have you written it down? I said it entails transfer of electrons, right, between metals and non-metal, isn't it? So, for example, an example of metals. Anytime you want to remember metal, this is the logic. This is the cheat. Metal will always have a positive charge. Is that taken? What did I say? Metals will have a positive charge. That is, they are losing electron. For example, sodium. Sodium is an example of metal. Calcium, magnesium. You know, sodium has Na plus. It has one charge. Simply means it is losing one electron in the outermost shell, isn't it? Do you still remember the electronic configuration we did last week? Are we together? Only gift is there. So you know, sodium is element number 11, right? So that is 2,8,1, isn't it? And that one, it will rather lose that one instead of gaining another 7 to obtain an octet structure. So that is why sodium is Na plus. So anytime you see plus as a valence, of an element, it simply means that element is a metal. Is that taken? So we have different elements: the sodiums, aluminum, magnesium, calcium, and so on and so forth. Once you see plus, plus 1, plus 2, plus 3, plus 4, but once you see minus, it simply means it is a non-metal, like chlorine. All the halogens, chlorine, you know, is -1, right? Fluorine -1, iodine -1, astatine -1, and every other compound that has negative, they are all non-metal. This is that taken. So now, if a metal and a non-metal, when they coexist together, like they are bonding together like husband and wife, the bond that exists between them is ionic bond. Ionic bond exists between a metal and a non-metal. So the first thing you need to do is to be able to identify this element is a metal, this element is a non-metal. So once they are bonded together, it is an ionic bond, or you call it electrovalent bond. But mind you, the metal is donating an electron, while the non-metal is receiving an electron. We get it? And the same number of electron that the metal is donating must be the same number that the electron the non-metal is receiving. As may I have my way to write, it will have been more easier for you. I'll just do a little explanation. So in the next class, I will just do the writing on the board. For example, let's check sodium chloride. You know, sodium chloride has ionic bond existing between them, isn't it? You know, sodium has Na+, chlorine has Cl-. Sodium is 28,1. That makes it 11. And while chlorine is 28,7. Chlorine needs one electron to have the octet structure. Have an octet structure. You know, if sodium does can you guys hear me now? So sorry for that. I don't know. This system is okay. Where are we? So we are talking. I'm trying to use maths to explain. I just hope you understand. Please, once you don't understand, please call my attention to it. Is that taking? So I was trying to explain ionic bond and electrovalent, but I was using sodium chloride as a case study. I said sodium is a metal. Hope you understand why it is a metal. Everybody, do you understand why sodium is a metal? If you don't understand, can you please thumb down? Do you all understand why sodium is a metal? Lillian, you don't understand how sodium is a metal? I said sodium, any element that has a positive charge is a metal. What did I say? Any element that has a positive charge is what? Is a metal in your first 20 elements, yeah, in your periodic table. So sodium has +1 because it is losing one electron. You know, sodium has an electric configuration of 2,8,1, isn't it? So that 2,8,1, sodium will rather lose that one electron in that outermost shell in order to have a complete octet structure, which is 2,8. Are we together? So that makes sodium a metal. And chlorine is a non-metal because chlorine it has a negative charge. You know, chlorine is Cl-. It has -1 because it will gain one electron to have a complete structure. If you remember the electron configuration of chlorine, it is 2,8,7. So if one electron is being added, it will become 2,8,8. So I was telling you that ionic bond exists between a metal and a non-metal. The metal is donating electron, while the non-metal is receiving or accepting the electron. And I said the same number the metal is donating must be the same number the non-metal is receiving. For example, sodium chloride. Sodium is donating one electron to chlorine, and chlorine is receiving one electron. So that is an ionic bond. Another textbook we call it electrovalent bond. It's still the same thing. Please, are we together? Is that clear? If you see MgCl2, MgCl2 also is an example of ionic bond. Magnesium is a metal, right? Chlorine is a non-metal. Magnesium is donating 2 electrons. We have 2 chlorine there, so they will be accepting the electron one by one. One chlorine will accept the first electron that magnesium is donating, and the second chlorine will accept the electron that the second electron that magnesium is donating. Assuming I have a way around to draw, I would have shown you the diagram, how it is being done. But in the next class, I will show you the diagram better. Is that taken? Hydrogen fluoride is an example of ionic bond. Sodium fluoride is an example of ionic bond. Sodium iodide and all. Please, is that taken? Once you see that it is between a metal and a non-metal, it is an ionic bond. Please, do we get the logic? Do we get the logic, please? Okay, so let me give you the properties. The properties of ionic bond. They have high melting points. Number one, they have high melting points. Can you write that down? And they conduct electricity when molten or they're in solution. They have high melting points. And they conduct electricity while when molten or in solution. So let's quickly move to the second part, covalent bond. Covalent bond. Like I said, I will explain more better in the next class. So this a covalent bond, they involve sharing of electrons. They involve sharing of electrons. And when we talk about sharing of electrons, who can tell me, will it be between a metal or non-metal, or between metals or between non-metals? Covalent bond is
Between
what?
metal.
Between non-metals.
Metals and non-metals.
No, metals and non-metals
No,
is
that's
ionic.
for electrovalent.
Metals.
What do you say?
Metal. Metals.
Non-metals.
Yeah, thank you. So covalent bond involves sharing of electrons between non-metals. Please write it down. Ionic bond involves the sharing of electrons between a metal and a non-metal. And we don't even call it sharing. Like I said, it is a transfer. But when you hear the word sharing, it is between non-metal and non-metal, and that is covalent bond. Please, are we clear with that? I don't think there's a way I can explain this better. When we talk about sharing between true non-metals and whole, I need to draw a diagram for you to show how it is shared. For example, let me say H2O. Hydrogen is a metal, oxygen is a non-metal, right? How many electrons does oxygen needs? Somebody help me. What is the electron configuration of oxygen, Lillian? Lillian, are you there? Can anybody help us?
So repeat your question.
What is the electronic configuration of oxygen? Oxygen is 2, what? It's not 2,6. These are all together. I can't
Two,
write. Please bear
two,
with me.
2, 6.
2,6, right? So that means for it to have an octet structure, what does oxygen need?
Needs to gain 2 electrons.
It needs to get 2 electrons. Now, we are bonding it with hydrogen, not just one hydrogen, 2 hydrogen. This simply means hydrogen needs 2 electrons at the outermost shell. You know, hydrogen has an electron configuration of 1. So it needs 1 to have 2 as the octet structure, right? Isn't it? These are all together. So now we have 2 hydrogen. That's why hydrogen will need that many electrons. It will need 2 electrons again. And that carbon also, that oxygen also needs 2 electrons. So the two of them will pair together, they will join together. So we call it symbiotic relationship in biology, if you remember, when the hosts and the is it the predator now and the prey, they are conjoining, like they are sharing it within one another. So that is what exists in covalent bond. You know, in ionic bond, it is like a parasitic mode of nutrition where one is donating, one is just receiving. Like the metal is giving out electron, the non-metal is just receiving. That is just like a parasitic mode of relationship. You used to remember. But in covalent, it is sharing. They are sharing together. Oxygen needs 2 electrons to have an octet structure. Hydrogen needs 2 electrons to have an octet structure. So hydrogen will release the electron. They will share it together. They will come together. So hydrogen will have a complete octet structure, while oxygen also will have a complete octet structure. Another example that I can give you is carbon dioxide, CO2. You know, carbon has, who can tell me the electron configuration of carbon?
2, 4.
2, 4. So carbon needs 4, or it needs to give out 4, one of the two, in order to have a complete structure. But carbon will rather receive 4. Are we together? Now oxygen needs 2. You know, we said it's 2,6, 2, 6. But now we have 2 oxygen. You know, you see O2. So that means 2 oxygen, we need 2 electrons. That makes it 4. Carbon needs 4. So the 4 will come together with the 4. So carbon will have 8. Oxygen 2 will have 8. Do you get the logic? Don't worry, I will draw in the next class. We understand it better. But do you get it to this extent? Only Justice is replying, no. Lillian. And the rest. Titi, are you still there? Okay, Paul. So just bear with me for today's class. I'm so sorry. So the properties of covalent bond. We have low melting point. You know, ionic bond has high melting point. Covalent is just like the opposite of ionic. So we have low melting points for covalent, and we have poor electrical conductivity, unlike the ionic bond that can conduct electricity. Covalent bond cannot conduct. They are very poor electrical conductive substance. Please, are we together? So the next one is metallic bond. Metallic bond. Metallic bond. Can somebody explain what metallic bond is? Any idea?
From the name implies metallic bond is just like metal sharing the electrons, the protons.
Sharing this thing. So when we talk about metallic bond, like the name implies, like is that just so hazy? As said, it is just a bond that exists between metals atoms. So everything under metallic bond is always between metals. Just metals. Is that taking? Ionic bond is between metal and non-metal. covalent bond is just between non-metals. Metallic bond is between metals. Do you get the corresponding? How it works? Like that. So from there, you should know that they are good electrical conductivity because they are metals, so electrons will move freely. These are the key characteristics or properties of metallic bond. And they are good heat conductivity. Please write it down. And they are malleable. They have high malleability. That is, they can be hammered into sheets. And the last one, they are ductile. They can be drawn into wires, like can be bent. So let's go to the fourth one. Coordinate dative bond. Coordinate dative bond. Please hope you are writing, please. Please hope you are writing now. All right. So coordinate dative bond, sometimes it can be confusing because it has a similar property with covalent bond. So this is one of the areas that can get confusing. You know, covalent bond talks about sharing of electron between non-metals, and coordinate dative bond, also coordinate bond or dative bond, anyone, also talks about sharing electron, but this electron, they appear donated by one atom. What it means is that coordinate bond is just a type of covalent bond where both electrons is coming from the same atom. You know, in covalent bond, the electron is not coming from one atom. It is coming from the two atoms, from different atoms like that are bonding together. Or in coordinate bond, both electrons in that shared pair is coming from the same atom. Please, do you understand? And anytime you see coordinate bond, one atom must have a lone pair of electron. If an atom does not have a lone pair of electron, that's a trick. It is not a coordinate bond. One atom must have a lone pair of electron, and the other atom must have an empty orbital that needs electron. So these are the two things you check. The first atom has a lone pair of electron, like nitrogen. You know, nitrogen has a lone pair of electron now. It must have a lone pair of electron, and the other atom must have empty orbitals. So the atom with that lone pair of electrons will donate both electrons to that one that has the empty orbit in order to form the bond. Please, do we get the logic? Lillian, do you get it? I'm not getting it. Okay. Do you get ionic bond? Do you get covalent bond and metallic bond? I hope everybody got that. All right. So the coordinate bond, like I said, you can also call it dative bond. Anytime you see dative bond, it's also coordinate bond. Like I said, it is very similar to covalent bond, but they are different. It is just like a special case of covalent bond. It also involves sharing of electrons. But in coordinate bond, the sharing of electron is only done by one atom. One atom will provide the electrons for the two elements that are pairing together. You know, in covalent bond, the two elements that are pairing together, they are both donating the electron. Like when we are checking H2O the other time, you know, hydrogen needs one electron to have an octet structure. Oxygen needs two electrons to have an octet structure. And we have two hydrogen. That means the two hydrogen will need two electrons to have an octet structure. So hydrogen needs two, oxygen needs two. So they will come together and have a complete octet structure. That is covalent bond. But in coordinate bond or dative bond, just one atom, which is a lone pair, we donate the electron to the other element that has an empty orbit. That other element will need electron. The first electron we have a lone pair of electron, so it will now donate it to the one that has an empty orbit, which needs an electron. So coordinate dative bond just talk about shared pair donated by one atom. That's just the best way you can understand it. Shared pair donated by one atom. Once it is one atom that is donating, it is synonymous to ion link, but it is not between metal and non-metal. It can be between non-metals and non-metals, like the covalent bond. But it's just one atom that is donating, one element that is donating the atom. Please, are we together? For example, NH4 plus. There's no way I will explain that without drawing. There's no way I can explain NH4 plus without drawing. Nitrogen is the no pair that is there, and hydrogen needs electron to fill it up. So nitrogen will donate the electrons, to donate both electrons for hydrogen to fill up. Is that taken? Don't worry, in the next class I will draw so that you understand better. Lillian, are you with us? Gifts, do you get it? Is Gift still in the class? Gift has one away. Okay, you are there. Gift Alpha, why are you crying? You've not eaten. Don't cry. Oh.
Is this last one that you explained? This coordinate?
The dative bond, Abby.
Yes.
I need to write. Let me see if the writing will work. It is not working yet. You can see the top corner. Everything is ash. They are not pressing. I don't know what's going on.
So are you trying to say that N, like I said, NH3 will donate a bond to the H, making it NH4?
Yes, the NH4 plus.
Okay.
So the nitrogen is the lone pair. Now I told you that in a dative bond, there must be a lone pair, and there must be an electron that needs an electron badly. So the lone pair will be the one giving out the electron. Do you get it, or I should explain better? Explaining is very difficult without drawing. I don't think if you can. Okay, let me explain better. Do you know nitrogen has 5 valence electron? Are we together? Hello? You guys are not here. In ammonia, you know, ammonia, nitrogen and hydrogen there. Do you know it is not dative bond? Who can tell me? It is covalent bond, right? So now in NH4 plus, it is no more dative, it is no more covalent bond, it is dative bond because of the presence of the hydrogen ion. The hydrogen ion simply means it has no electron and it needs 2 electrons to form a bond. So the formation of dative bond simply means nitrogen will not donate 2 lone pairs of electrons to that hydrogen ion in order to have an octet structure. Saying it by mouth is very difficult because there's no way to write it down.
So what about you share your screen, then use a notebook to explain?
I don't have it on my notebook. Oh. If I share my screen, I don't know if you can understand my textbook. I also have the things I want to teach you. Like I don't write on my screen. I don't write on my notebooks. It's just like a scheme of work. I don't know if you know scheme of work. Yeah. I have my definitions there, but I don't have the explanation there. Don't worry, I will come again in the next class. Bear with me. The dative bond, just asterisk it. In the next class, I will explain. It's very simple. In dative bond, like the ionic bond, you always have a donor. You always have an acceptor. Do you get it? The donor must be the one that has the lone pair. And majority of the time, it is always nitrogen. that has the lone pair. Are you with me? And there must be an acceptor. Now, if you check NH4 plus, nitrogen is the one donating the lone pair to hydrogen ion, which helps to form that dative bond. Because if you look at it, NH4 plus, hydrogen, like I said, it needs electrons to have the octet structures. Because the plus shows that it is losing electron, and that means it is losing 2 electrons. Because hydrogen has 1 before. So that means if it loses 1, it has a 0. So nitrogen will be the one to donate the lone pair to the hydrogen. It's very simple.
Okay, sir, I understand.
Do you understand now? But others, do you understand? Let me go online. Let me see if I can see the diagram. I'll just copy it and send it to you. Just give me like few seconds. Let me quickly look. Lillian, do you get it? Gifts, do you still need food or you need diagram? Which one? AZ, do you get it? You need both, I know.
Sir, I don't get it. I don't get
You
it.
don't get it? Yeah. Okay. I'm coming. I'm looking online already. Let me see if I will get. Let me see if I can get the diagram. So I'll use that diagram to explain.
Sir?
I'm coming. I'm trying to look for diagrams. Even the diagrams I saw now, you will need. So we need a generic. Let's just move on. Don't worry. Let's go to hydrogen bond. I will come again in the next class. I'm sorry for that. So hydrogen bond is just a bond that exists when hydrogen bond to another electronegative atom. I think that's the easiest definition. Hydrogen bond is a kind of bond that exists when hydrogen bond with another electronegative atom. Example of electronegative atoms are what? Atoms that has negative charge. Examples, anybody? Nitrogen, right? Oxygen, chlorine, and all. So you must not confuse. Yeah, thank you. So hydrogen bond occurs when hydrogen is attached to highly electronegative atoms. Highly electronegative atoms. And somebody answer this question. Is water a covalent bond or hydrogen bond? Submit it on the group. And you can submit it now. Is water a hydrogen bond or covalent bonds? An hydrogen fluoride, is it covalent bond or ionic bond? I have my reasons for asking this question. Because these are the questions you will see. Give said covalent bonds. Water is covalent. But we said when hydrogen bond involve interaction between hydrogen and highly electronegative atoms. Oxygen is a very high electronegative atoms. So why can't you call it an hydrogen bond?
I don't, because they are sharing. They are sharing this
I know
thing.
they are sharing. That's why you said it is a covalent bond, right?
Yes.
I want you to go and make more research on it and tell me.
I
Tell me on
think
the Lillian Alpha. You want to talk?
I think it's both.
Mm-hmm. Why?
And,
Uh,
You are
but
getting it. Oh.
but hydrogen fluoride is hydrogen bond.
Hydrogen fluoride.
Yes. She also
Okay.
asked it.
What about hydrogen chloride?
Um it will be hydrogen bond.
Why? Is hydrogen chloride
Because it
is
is
chlorine a high
electronegative.
is electron, but is it a highly electronegative element?
Yes.
Eh.
It's hydrogen chloride. I
Now, for
don't
hydrogen chloride,
it's covalent bond.
Hydrogen fluoride.
I think his network is bad. But you guys, what do you could think? Because I feel hydrogen chloride and water are covalent. Why hydrogen fluoride is hydrogen bonding? But I'm not really sure why. What do you guys think?
Sorry guys, I lost my network. All right, so don't worry, we will address it better because like I said, this aspect, and they will be testing a lot of things. Lillian was actually getting it a little bit before.
I think it's covalent because hydrogen will be the one to donate to chlorine to be able to complete the shell.
Okay, another
Sir,
another point of view.
sir.
Is that justice?
No, it's Paul.
Yes,
Paul.
yes, it's justice.
Okay. Oh,
Sir,
you want to say
I,
something?
yes, I want to say something. Sir,
I can hear you.
occurs between covalent bond occurs with hydrogen fluoride and water because it's an interatomic bond. It occurs within the atoms of the elements. But
Between hydrogen fluoride and water.
yes, but
Does that
hydrogen
mean
bond
hydrogen fluoride does not have any other bond again?
no hydrogen bond actually occurs there, but
Very
it's
good.
intermolecular now, not
Mm.
atomic. So it's more like hydrogen bond is like a secondary bond,
Mm.
while covalent is the primary
Primary
one.
bond.
So hydrogen comes when there is covalent bond between hydrogen and negatively charged.
Okay. Yeah, getting it. That's totally correct. What about hydrogen chloride?
And so I said something about that hydrogen chloride.
Justice, what do you say again? So
I said that chlorine has 7 shells at the outermost part. So
7 shell or 7 electron
7 electrons, sorry.
in
So
that much.
hydrogen has 1. It will donate that one to chlorine to make it 8.
Okay, so what will happen to hydrogen?
Hydrogen will then have 2 Z because of that innermost distinction or something like that.
So what type of bond does this in nature?
Covalent.
Covalent. Do we all agree? Do we all agree? Ah, okay. Yes, you are also right. Justice. That's correct. Covalent bond exists between hydrogen. I will tell you the reasons. Hydrogen can behave as a metal and no metal. Okay, Asa said yes earlier. Hydrogen. So in that case that Justice was explaining now, hydrogen was trying to become or behave like a noble gas, trying to have an octet structure, while chlorine also is trying to have an octet structure. So at that instance, hydrogen is not donating an electron. They are both sharing the electron within themselves. So hydrogen and chlorine, they are sharing the electron. So the bond is covalent. But chlorine is more electronegative than hydrogen. And that is why the electrons are shared unequally. All these things, there's something we call polar covalent. So the covalent nature that exists between hydrogen and chlorine is polar covalent. So like I said, I don't want to go deep, but I'll just make it simple in the next class. But we need to draw. But it's very simple, believe me. At least they will have like two questions or three questions from this chemical bond and all. But uh hydrogen bond does not occur in HCl. So, and the reason is actually that hydrogen in HCl is attached to chlorine. How will I be saying it now? Just know what I think. Let me just give you the properties. In the next class, we take it all over again. We check examples, then we check jam pass questions together. So I won't make you get lost on, because a few of you are getting it, but some of you are not getting it. And I want to carry as much as possible people along in the class. So HCl, you look at like, hydrogen is a covalent. Hydrogen is hydrogen and chlorine. Since it's an electronegative element, it should be an hydrogen bond. So what happens? And how? So just bear with me. Is that taken? So I would like to we will check the Van der Waals force in the next class and the properties of hydrogen bond. I want to end in hydrogen bond so that I can have a proper explanation of it. I will mark your test in the evening when I'm done. I will send the answer. No, we check the answer first in the next class. I think that would be appropriate. But the mark for everybody will be submitted on the group. So we are not making jest of anybody. Don't make jest of anybody. So some people can have 50% in the test, and in the jam they will have 75%. So it's not about what you have now, it's about what you have in your jam. Is that taken? So the first reasons why we did this is to ensure you understand what you've learned so far, because it is like about a month and a few days to your jam exam now. We should be doing your mock, a proper mock test, a mock exam before your jam. But I just want to know how far you understand the 6 chapters that we've done so far. Is that okay? So we will see in the next class. So then, please do well to have a good day and enjoy yourself. Thank you, gifts. Linia, Suzanne, bye bye. Justice, where's your love emoji? You are fighting me. Don't fight me. Paul, thank you. Bye. Take care of yourself. Yeah, thank you, Titi. Oh, you are in the class. Sorry. Bye bye.
Thank you, sir.
Yeah, take care now.
Good afternoon.